Welcome everyone to our Algebra series, the SSCE aspect of it. Today we'll be continuing with our factorization, which is a subtopic. But under that subtopic, we'll be taking difference of two squares expressions. These are expressions of the form x squared minus y squared equals to x minus y, bracket open and close, into another bracket, open, x plus y, bracket close. Let's take our first example. Factorize 25y squared minus 4. The options are given. Solution. Working with an eye of difference of two squares, we can now transform our given problem 25y squared minus 4 equals to 5 square y squared minus 2 square. Now we can further simplify to take it to be 5y, bracket open and close, square minus 2 square. What we are trying to achieve is to achieve the pattern of difference of two square, which says x squared minus y squared equals to x minus y, bracket open and close, then another bracket s plus y. So we transformed our 25 to 5 square, and y square is already there, and you know that 4 is 2 square. So simply, since we have achieved square on both the two items given and minus is in between them, then we know we are good to go. So we now have 5y minus 2, bracket open and close, into another bracket open, 5y plus 2. And that is our result, how far we are expected to go. Let's take another example. Factorize 8ab squared minus 32a squared. The options are given. Working with an eye of difference of two squares. Now, our given problem, which is 8ab squared minus 32a cubed, that will be equals to, we factor out 2a. Then we now have a bracket open, 4b squared minus 16a squared. Finally, we're getting values that will suit difference of two squares expressions. Make it proper. Let it appear properly. So we have 2a. Let it appear properly. So we have 2a into bracket open. Then we now have 4b squared will now be 2b. Then you guide it with a bracket open and close square. Minus 16a squared will now be 4a into bracket open and close square. With this, we have achieved the desired goal of difference of two square, which is x squared minus y squared equals to x minus y, bracket open and close, into another bracket open, s plus y. So now we proceed. That will give us 2a into bracket open, 2b minus 4a, to another bracket open, 2b plus 4a. From there, we can factor out 2 from our bracket, since 2 is common all through, and that will give us 4a into b minus 2a to bracket open b plus 2a. That is how far we are expected to go in this given problem. Another example. Factorize 5d minus 2e, bracket open and close, square minus 9e square. The options are given. Solution. Working with an eye of difference of two squares, our given problem, which is 5d minus 2e, bracket open and close, square minus 9e square, will be equals to 5d minus 2e, bracket open and close, square minus 3e, bracket open and close, square. We've just tried to make the 9e square to knowing that 9 is the same thing as 3 square, so that we can get a perfect expression that aligns with x squared minus y squared. Now, since we have arrived at that, we can go further to give the result, which is 5d minus 2e, bracket open and close, minus 3e, bracket close, into another bracket, 5d minus 2e, bracket open and close, plus 3e. Once that is achieved, we can now open up bracket within bracket, and that will give us 5d minus 2e minus 3e, into another bracket open, 5d minus 2e plus 3e. Simplifying further, we now have 5d minus 5e, bracket open and close, into another bracket open, 5d plus e, bracket close. The first bracket, we can simplify 5 out of it, and we have 5 into d minus e, bracket open and close, into another bracket open, 5d plus e. And that is how far we are expected to go in this given problem. Another example. Factorize 50k raised to power 4 minus 8b squared. The options are given. Solution. Working with an eye of difference of two squares, will be expected to rearrange our given problem in a such a way that it will fit x squared minus y squared without necessarily altering the figures given. So we have 50k raised to power 4 minus 8b squared will be equals to 2. We factor out 2, we'll now be left with 25k raised to power 4 minus 4b squared. From here, we have gotten a clearer picture of the given problem. So we know that 25k raised to power 4 can become 5k squared, bracket open and close, raised to power 2 minus 2b squared, 2b bracket open and close square. 4b square is what we have transformed to 2b, then squared it. Next, we can proceed to, since we have achieved the result of x squared minus y squared, we can now proceed to say, okay, our given items become 5k squared minus 2b. Don't forget to write out your 2 that is factored out of the bracket, and that is how far we are expected to go in this given problem. Another example. Use the idea of difference of two squares to find the exact value of k in the equation. 24k equals to 106 square minus 94 square. Solution. First of all, we write out our given problem. From here, we now simplify the right hand side. We now have 24k equals to, applying difference of two square to 106 square minus 94 square. We now have 106 minus 94, bracket open and close, into another bracket open, 106 plus 94, bracket open and close. And the result will be 24k equals to 12, bracket open and close, into bracket open and close, 200. What we have just done is 106 minus 94 gave us 12, and 106 plus 94 gave us 200. 24k will be equals to 2,400. Next, we can divide both sides by the coefficient of k to get k. K will be equals to 2,400 divided by 24. And that is to say k is equals to 100. Another example. Factorize completely. X squared plus x, bracket open and close, raised to power 2 minus, bracket open, 2x plus 2, bracket close, raised to power 2. Solution. Applying difference of two squares, we have our given expression, which is x squared plus x, bracket open and close, square, minus 2x plus 2, bracket open and close, square, will be equals to x squared plus x, bracket open, plus 2x plus 2, bracket open and close. Then we have a bigger bracket to enclose this first two item. Then into another bracket open, then we have a smaller bracket being open, x squared plus x, bracket open and close, there, minus 2x plus 2, bracket open and close. Then before we close it with the bigger bracket. What we have just done, we are applying our difference of two squares to the two items given. And the result, we open up bracket within bracket. So we now have x squared plus x plus 2x plus 2, bracket open and close, into another bracket open, x squared plus s minus 2s minus 2, bracket close. Simplifying the expression, you have each of the bracket expressions. We have s squared plus 3s plus 2, bracket close, into another bracket open, s squared minus s minus 2, bracket close. Next, we factorize each quadratic expression. Factorizing each quadratic expression, we now have x squared plus 2s plus s plus 2, bracket open and close, into another bracket open, s squared minus 2s plus s minus 2, bracket close. And our result will be x into the first bracket, you factor out x, then you have x into x plus 2, bracket close, plus 1 into x plus 2, bracket close. Then before you close the bracket, and you go to the next item, which is x into bracket open, x minus 2, bracket close, plus 1 into x minus 2, bracket close. Then you close the bigger bracket. And that will give us x plus 2 into x plus 1, bracket open and close. Then into the bigger bracket, x minus 2, bracket open and close, into x plus 1. And that will give us our beautiful result as x plus 2, bracket open and close, into x plus 1, into another bracket open, x minus 2, into another bracket open, x plus 1. That's the end of the examples under difference of two square expression. Next, we have some exercises, which I will advise strongly you try your hands on them. Next, we proceed to the subtopic here under factorization. We'll be dealing with trinomial expressions. These types of expression are always in three terms. The method of solving trinomials, which are mostly quadratic, that is a s squared plus bs plus c in nature, is in two ways. First, we take when the coefficient of s squared is unity, that is a equals to 1. Examples: factorize s squared plus 2s minus 3. Solution: we find the factors of c, that is minus 3 in bracket, that when added together gives us b, that is comparing the given expression with a s squared plus bs plus c. Now let's list out our factors. Factors of minus 3 and the sum that is supposed to give us plus 2. Minus 3 and plus 1. The summation will give us minus 2. Plus 3 and minus 1. The summation will give us plus 2. So this last pair of factors will suit our work. The factors of plus 3 and minus 3 satisfies our condition. Thus, we can now write out that our given expression, which is s squared plus 2s minus 3, is equals to s squared plus 3s minus s minus 3. What we have just done, we changed the 2s now. Instead of 2s there, you now change it to the value which you have from the factors. 2s become plus 3s minus 2x. If you wish to reverse it back, you will see that you get back to where you are coming from. From there, we can now factor out x, and we have x plus 3, bracket open and close, minus 1 into s plus 3, bracket open and close. From there, we can factor out s plus 3 is common. Once it's factored out, you now be left with x minus 1, completely factorized. Another example. Factorize completely x squared minus 4s minus 12. Solution. As usual, we find the factors of c, that is here is minus 12, that when added will give us b. In this case, is minus 4. We write it out. Factors of minus 12, then the sum. Let's start with 12 and minus 1. The summation of 12 and minus 1 is plus 11. Then we proceed to take 3 and minus 4. When we take 3 and minus 4, the summation is minus 1. Now let's take 2 and minus 6. Those two factors, when multiplied together, will give us minus 12. And when summed together, will give us minus 4. The last factor of 2 and minus 6 satisfies our condition. Thus, s squared minus 4s minus 12 is equals to s squared plus 2s minus 6s minus 12. We are changing our minus 4s into 2s minus 6s, which is the factors we got. Now, we can factor out x from the first two given values there. And when we factor out s, we now have x plus 2, bracket open and close, minus 6. And we have x plus 2 again, bracket open and close. With that, we can factor out our s plus 2. And we'll be left with x minus 6, properly factorized. Note, to be objective-minded, readers or learners need not go through long process of trial and error before arriving at the needed factors. Let's take another example. Factorize s squared plus 7s plus 12. The options are given. Solution. Here, the factors of 12 that when added gives us plus 7 are 3 and 4. So we can now change our expression. The given expression s squared plus 7s plus 12 will be equals to s squared. Instead of 7x there, we now have 4x plus 3x, which are the factors we got, plus 12. Then we can now simplify further. Factor out x. In the first two expressions, you now be having x into x plus 4, bracket open and close, plus 3. Then you now have x plus 4, bracket open and close. And from this, we can factor out our s plus 4 from both items, and you'll be left with s plus 3. Next, we have some exercises, which I will advise strongly you try your hands on them. Next, under trinomial expression, we are going to the second method, which is when the coefficient of s squared is not unity, minus 1 inclusive. Here, we look for the factors of AC that when added will give us b from the quadratic expression as squared plus bs plus c. Examples: factorize 12 plus 11s minus s squared. Solution: a is not equals to 1, rather a is equals to minus 1. Thus, our AC will be equals to minus 1 times 12. That is minus 12. And our B is equals to plus 11. Next, we'll be finding the factors of minus 12 that when added gives us plus 11, which are plus 12 and minus 1. We can conveniently say now that our given expression, which is 12 plus 11s minus s squared, will be equals to 12 plus 12s minus x minus s squared. We are just changing our 11s, which is the center item, to, instead of being 11s, become 12s minus x. Next, we can now factor out 12 from the first items, and that will be 12 into bracket open 1 plus s. Then we factor out minus s in the last two items, and when we do that, we will be left with minus s into bracket open 1 plus s. Now 1 plus s is common to both sides, so we factor it out 1 plus s, and we left with 12 minus s. That is how far we are expected to go. We take another example. Factorize 2y squared plus 11y plus 15. Solution. Our AC here is equals to 30, and our B here is equals to 11. I hope you know how we got our AC. That is 2 times 15. Trying the factors of 30 that when added gives us plus 11. We have plus 6 and plus 5. So we can write out our given expression as that is 2y squared plus 11y plus 15 will be equals to 2y squared plus 6y plus 5y plus 15. Then we can now factor out 2y from the first two items, and we have 2y into bracket open y plus 3 bracket close plus 5. We factor out 5 in the last two items, and we'll be left with 5 into y plus 3. Now y plus 3 is common to both brackets, so we factor it out. Y plus 3 bracket open and close into, you'll be left with 2y plus 5. Another example. Factorize 5x squared plus 7xy plus 6y squared. Solution. Here we treat the equation which appears in square of two different functions as one square of a function of x. Thus, our AC here will be equals to 30 and our B be equals to 17. AC here, I hope you know how we got that 6 times 5, which is 30. The factors of plus 30 that when added will give us plus 17 are plus 2 and plus 15. Thus, our given expression can be written as 5s squared plus 17xy plus 6y squared will be equals to 5s squared plus 15xy plus 2xy. The pattern we have been following, you transform the center item into the given factor that we have arrived at, plus 6y squared. Now we can factor out from the first two items 5x, and you'll be left with, we have 5s into x plus 3y, bracket open and close. Then the last two items, you can factor out 2y plus 2y, will now be left with x plus 3y. And from here, x plus 3y is common to both brackets, so you bring it out, and you'll be left with 5s plus 2y. That is how far we are expected to go. Another example. Factorize the expression 42 minus 15x minus 3s squared. The options are given. Solution. First, when you look at this problem, the first approach will be to factor out a common number among the given item. That will now enable us to work with the given quadratic equation. That will be, we have our 42 minus 15x minus 3s squared will be equals to 3 being factored out, open up the bracket, 14 minus 5s minus s squared, bracket close. Immediately this have been done, we can now proceed to work as it ought to. Here, our AC is minus 14, and the factors of minus 14 that when added up will give us a minus 5 are minus 7 and 2. Thus, our 3 into bracket open 14 minus 5s minus s squared will be equals to 3 into bracket open 14 minus 7x plus 2x minus s squared, bracket close. Now we still have our 3 there, and we can now factor out 7 out of the first two items. We have 7 into 2 minus s, bracket close, plus we factor out s from the last two items, and that will be s into bracket open 2 minus s, bracket close. Now 2 minus s is common to the two brackets, so we bring it out. Not forgetting your 3 that is still there before now. We now have 2 minus s, and you'll be left with 7 plus x. Close your bracket. That is how far we are expected to go in this problem. We've come to the end of the examples under this subtopic. Next, we have some exercises at page 36 of the hidden fact in SSCE mathematics. Advise you try your hands on the exercises which are given. The answers are the answer section of the book, either the hard copy or the soft copy. Thank you.